Robert Lanza was called by the New York Times one of the three most important scientists alive today. Just to give you an idea of the caliber of our next presenter.
Well, I'd like to thank Mauricio and the organizers for having me here, but I do have to say that yesterday I was at Logan Airport on my way here, and I was just about ready to get on the plane, and lightning struck the airplane and fried the electronics. And so while I was waiting there for the next airplane, I thought maybe someone is trying to send me a subtle message. But anyways, I would like to talk to you here about biocentrism, which is a new theory of everything which arrives at the same conclusions as non-duality. So every now and then a very simple but radical idea shakes the foundations of knowledge. So when the discovery of the earth, that it wasn't flat, challenged the way people perceived themselves and their relationship with the surroundings. Our ancestors were challenged to believe that the earth was round even though the ground they walked on was flat. And nothing in everyday experience revealed anything about the truth of this idea. So if the earth was really round, it was argued that people at the bottom would fall off. So it was considered complete nonsense 500 years ago. So likewise, biocentrism is turning the world upside down again, with the seemingly simple idea that the universe arises from life, not the other way around. So switching the perspective of the universe from physics to biology undoes everything we know about the universe and life in it. We think that life is just an accident of physics, but a long list of experiments suggests exactly the opposite. Amazingly, if you add life and consciousness to the equation, you can explain some of the biggest puzzles in science. For instance, it becomes clear why space and time, indeed the properties of matter themselves, depend on the observer. It also becomes clear why the laws of the universe itself are fine-tuned for the existence of life. So until we recognize the universe in our head, attempts to understand the world remain a road to nowhere. So scientists fail to recognize those properties of life that make it critical for our existence. So the view of the world in which life and consciousness are bottom line to understanding the larger universe is called biocentrism. And it revolves around the way our consciousness relates to a physical process. It's a vast mystery that I've pursued my entire life with a lot of help along the way. So I've come to conclusions that would shock many of my colleagues and predecessors, placing biology above the other sciences, in particular physics and chemistry, in an attempt to understand a theory of everything that has eluded these other disciplines. We're taught since childhood that the universe is divided into two entities, ourselves and that which is outside of us. So this seems logical. Self is commonly defined by that we can control. So I can move my fingers, but I can't wiggle your toes. The dichotomy then is based largely on control and manipulation. So the basic biology, however, tells us that we don't control most of the trillions of cells in the body any more than we do control a rock or a tree. So consider everything around you right now. Me up here at the podium, your hands, your body. Language and custom all say that that's outside us in the external world. But you can't see anything through the vault of bone surrounding your brain. Everything you see and experience right now, your body, the walls, the ceilings of this room, are an active process that's occurring in your mind. You are this process. You're not just the part that you control. So your eyes just aren't portals to the world. You think you just see out there, but again, you can't see through the cranium. So what you're seeing, again, is everything that you think right there is out there is actually a construction happening moment to moment in your mind. So again, I want to emphasize that this is all happening in your head, and even the light from the bulbs in this room, they're moving through a space that's actually created in your mind. So consider everyday reality. So for instance, the weather outside. You see a blue sky out there, but the cells in your brain could be changed so that everything that's blue looks green or red. Could even do a little genetic engineering so that everything that's red makes a noise or vibrates or makes you want to have sex like some birds. Or, for instance, you think it's bright out, the circuits in your brain could be changed so that it's dark. You think it's hot and humid, but to a tropical frog it would look cold and dry. So this logic applies to virtually everything. Bottom line is, and the first principle of biocentrism is that reality involves your consciousness. It could not be there without your consciousness. Emerson once said, "We have learned that we do not see directly, but mediately, and that we have no means for correcting the colored and distorted lenses which we are, or of computing the amount of their errors. Perhaps these subjective lenses have a creative power. Perhaps there are no objects." So why is everyone surprised at the experimental findings of quantum theory? It's because we're still operating in a severely outdated paradigm. We still believe there's an external world that exists independent of the perceiving subject. So philosophers and physicists from Plato to Hawking have debated this. Niels Bohr, the great Nobel physicist, once said, "Not so. When we're measuring something, we're forcing an undetermined, undefined world to assume an experimental value. We're not measuring the world, we're creating it." And this is from a physicist. And at the legendary debates, Einstein presented ingenious ideas supporting the idea of a real world out there. But Bohr shot every one of them down one by one and gradually convinced his colleagues of his point of view. Today, however, most people still believe there's an external world out there. This issue, of course, is ancient and predates biocentrism, which of course explains why one view and not the other has to be correct. So let's consider a little of the physics, the real experiments. Consider the famous two-hole experiment. When scientists watch a particle go through two holes in the barrier, it acts like a little bullet and logically goes through one hole or the other. But if you don't watch it, it behaves like a wave and can go through both holes at the same time. So why should a particle out there change its behavior depending on whether you watch it or not? And of course, the answer is that reality is a process that involves your consciousness. And again, there have been many, many versions of that experiment. Consider Heisenberg's famous uncertainty principle. If there was really a world out there with particles just bouncing around, then we should certainly be able to measure all of their properties. But you can't. So for instance, a particle's exact location and its momentum can't be known at the same time. So why should it matter to matter or to particles what you decide to measure? Again, the answer is simple. The particles aren't just out there. Again, we can go on and on. One more, entangled particles you've probably heard of. How can particles possibly instantaneously be connected at opposite sides of the galaxy out there in violation of the speed of light? Again, they're not just out there. Space and time are tools of our mind. They're forms of animal understanding. So this is the problem, in a nutshell, is that we look at the world like a chipmunk or a squirrel. The squirrel opens his eyes and sees the acorn, and it's just miraculously there. He grabs it and he scurries up the tree without any further thought. And we humans are the same. We wake up in the morning and the world is just magically there. We go through life, we drool, completely oblivious to what's going on around us in the world. But experiment after experiment shows that not a single particle out there exists with real properties until it's observed. So it doesn't take a genius to realize that reality is a process, again, that involves consciousness. So what we need to do is replace the old physics with a new biology. Space and time aren't these hard, cold objects out there, sort of like the pebbles and the shells you pick up along a seashore. No, wave your hand through the air. If you take everything away, what's left? Nothing. And the same thing is for time. You can't put it in a bottle like milk. So again, all of experience is just information that's occurring inside your mind, and space and time are the mind's tools for putting it all together. We even do it in dreams. With your eyes closed, you can be on the beach with bright lights just as real as we are here in this room. Your mind has the ability to create space and time just like it does in dreams. And in schizophrenics, anyone who may be a doctor realizes that those patients see people right beside them and reality just like this, just as real as you and I right now. But that's just part of the equation. Again, you have to look at what's going on in science, not just with the experiments, but in terms of observation. So it turns out that biocentrism may be the only rational way to explain the structure of the universe itself. So the cosmos, it turns out, has a long list of traits that make it appear as if everything was exactly tailor-made just for us. And some are calling this the Goldilocks principles, after the old nursery tale of the three bears who try different bowls of porridge. Some of the bowls are too hot, some are too cold. And the bears also try different chairs and beds. And each time the third bear finds that everything is just right. So likewise, the cosmos has an incredibly unlikely list of traits that make it not to this, not to that, for life to exist. So for instance, the Big Bang, if it was 1 part in a millionth more powerful, it would have rushed out too fast for galaxies and worlds to be here. Again, the result, no us. If the strong nuclear force would decrease by 2%, atomic nuclei would not hold together. Plain vanilla hydrogen would be the only element in the universe. Again, if the gravitational constant were decreased just a hair, stars, including the sun, wouldn't ignite. There are over 200 parameters so exact. These could be any number, anything, but they're exactly just right for life to exist. And so, again, if you tweak any of them, you never existed. So none of these are predicted by any theories, and they all seem exactly carefully to allow for life. And of course, it's been hijacked by intelligent design folks, but it doesn't mitigate the problem of why these constants are all exactly one way when they could be millions of other parameters. So one way is to say God did it, and the only scientific explanation is something called the so-called anthropic principle, which says that we must find these conditions because if we're alive, what else could we find? Well, of course, that really isn't an explanation. That's unless you say there are an infinite number of universes, and we just happen to live in the one lucky one where all the parameters, all the parameters are exactly right. And again, just 1 in a gazillion. Certainly we can do better than that. So obviously no universe that would allow for life could possibly exist from a biocentric point of view. The universe and all of its parameters simply reflect the spatial temporal logic of the animal observer. So it turns out the long sought after theory of everything is really just merely missing one important component that was too close to us to have noticed. So some of the thrill that came with the announcement of the human genome had been mapped, or that we're understanding the Big Bang. It rests in our desire for completeness and totality. So these comprehensive theories, all of them, feel right now to take into account one critical factor, and that is that we're creating them. We're the biological creature that fashions the stories, that makes the observations, and it gives names to things. And therein lies the great expanse of our errors. And that is that science hasn't confronted the one thing that's most familiar and most mysterious, and that is, of course, consciousness. So for several centuries, a single mindset has dominated scientific thought. This model has had countless insights and applications that have transformed all of our lives. But it's now reached the end of its useful life. This old model proposes that the universe was until recently just a lifeless collection of particles just bouncing around each other. And they were following these predetermined rules that were mysterious in their origin. And the universe was presented like this watch that had somehow wound up and then now is unwinding and allowing for a little quantum uncertainty, will unwind in a semi-predictable way. Of course, there are lots of problems with this paradigm, some that are obvious, others that are rarely mentioned, but just as fundamental. But the overarching problem involves life. How life arose originally is still an unknown process, even though we can follow it and apprehend what's been going on since through Darwinian mechanisms. The bigger problem is that life contains consciousness, which is, to say the least, poorly understood. So consciousness isn't just a problem, though, for us biologists. It's a problem for physics. And there's nothing in physics that can explain, as you've already heard over and over, how a group of molecules in the brain creates consciousness. So the beauty of the sunset, the taste of a delicious meal, these are all mysteries to science, how we subjectively feel that. So how can something we can, like in neuroscience, we can pin down in the brain where parts of these occur. But what's really worse is that science can't explain how how consciousness arrives from matter. So our understanding of this most basic phenomenon is virtually nil. Interestingly, most of the models of physics don't even recognize this as a problem. But let's put aside all the life and consciousness issues. The current model scientific paradigm leaves a lot to be desired when coming to try to explain the fundamentals of our universe. The universe, indeed, all the laws of nature themselves just suddenly popped out of nothing one day for no apparent reason. And we call this titanic event the Big Bang. And we don't even begin to understand the Big Bang, even though we keep tinkering with all the different parameters in expansion, for instance. But again, the Big Bang, we all know, is really not an explanation at all. At some point, virtually everyone has thought, this doesn't really work. This doesn't really explain anything fundamentally, not really. So when it comes right down to it, science is amazingly good at figuring out how the parts work. But what eludes us is the big picture. We create these exquisite technologies from our ever-expanding knowledge of the physical processes. We do badly in just one area, which unfortunately encompasses all bottom-line issues. And that is, what is the nature of this thing we call reality, this universe as a whole? In any honest summary of the current state of explaining the universe as a whole, it's a swamp. And this Everglade is one where alligators of common sense have to be evaded at every turn. So some scientists insist that the theory of everything is just around the corner and that we'll eventually know everything, and any day now. And this isn't going to happen, and it hasn't happened for a reason. And that is because we've shunted a very critical component out of our view, and that component, of course, is consciousness. And it's not just a small item. It's not like anything else. Indeed, it's nothing like anything else. Consciousness is awareness, it's perception, and in an utter mystery, we think it somehow just arises from goo. So how did inert, random bits of carbon ever morph into that Chinese guy who always wins the hot dog eating contest? So in short, the attempt to explain the universe, its origins, its parameters, and what's really going on requires us to understand how the observer, us, how our presence plays a role. So at first this may seem impossible, since much of consciousness still is mysterious. But as we shall see, we can use what we know and what we are increasingly learning to formulate models of the universe that make more sense for the first time. So undeniably, it's the biological creature that makes the observations, that creates the theories. And our entire education system, indeed the construction of language itself, revolves around that bottom line mindset that assumes there's a separate universe out there, which each of us individually arrives at on a very temporary basis. It's further assumed that we accurately perceive this external, pre-existing reality, and we play little or no role in its appearance. However, starting in the 1920s, the results of experiments have started to show just the opposite. So the observer, it turns out, critically influences the outcome. An electron, again, as I mentioned earlier, can be both a particle and a wave. But how, and more importantly, where that particle will be located, depends on the actual act of observation itself. And again, this is most famously illustrated in the two-hole experiment, which has been performed so many times in so many variations that it's conclusively been proven that if you watch a subatomic particle or a bit of light pass through two slits in a barrier, it will behave like a particle. And it creates these solid-looking hits on a barrier that the physicists can measure. And so like a bullet, it goes through one hole. But again, if you don't observe its trajectory, the particle then exhibits the behavior of a wave and can go through more than one hole at the same time. And since then, the list of paradoxes and intractable problems has continued to grow, starting with those accompanying the Big Bang. For instance, how could the entire universe just arise out of nothingness? Experiments during the past decade have also shown that separate particles can influence each other again over enormous distances as if they were endowed with a kind of an ESP. So these and similar experiments have befuddled scientists for decades. Some of the greatest physicists have described them as impossible to intuit. How can quantum physics be so impervious to metaphor, to visualization, and language? Amazingly, if you accept a life-created reality at its face value, all of it becomes straightforward to understand. So take the undeniable logic, or the seemingly undeniable logic, that your kitchen is always present. You think that its contents assume its familiar shapes and colors, whether or not you're in it. But consider, the shapes, colors, and forms known as your kitchen are seen because the particles of light from the overhead bulb bounce off the various objects and then interact with your brain through a complex set of retinal and neural intermediates. But on its own, as you heard from the previous speaker, is that light doesn't have any color, nor any brightness, nor any visual characteristics at all. It's merely an electrical and electromagnetic phenomenon. So you might think that the kitchen was there in your absence, but unquestionably the reality is that nothing remotely resembling what you perceive as your kitchen could possibly be there without your consciousness interacting with it. Quantum physics comes at it from a much harder angle and arrives at the same conclusion. So at night you click your lights off and you leave for the bedroom. And of course the kitchen is there unseen all through the night, right? So in fact, the refrigerator, it turns out, the stove, and everything in your kitchen are composed of a shivering swarm of energy. And the results of quantum physics, such as the two-hole experiment and others, tell us that not a single one of those particles in any of those objects actually exists in a definite space until you observe them. Rather, they exist in a range of probabilities, waves of probability, as Max Born, the German physicist, once said. So outside of that fact, there's really nothing there. They're just statistical probabilities of particles existing in certain locations. So if they aren't being observed, they can't be thought of as having any real existence, either duration or position in space. So it's only in the presence of the observer, that is when you go back and get a drink of water, that the mind actually sets the scaffolding of these particles in place. And it's not until the mind actually lays down the threads somewhere in that haze of probabilities that's described by the uncertainty principles, can they be thought of as being either here or there, or of having actual position or a physical reality. Indeed, it's here where biocentrism suggests a very different view of reality. Most people, both in and outside of the sciences, imagine the external world to exist on its own with the appearance more or less that resembles what we see outside us, or what we see ourselves. So animal or human eyes, according to this view, are merely clear windows that accurately let in the world. So if the personal window ceases, such as in death, or is painted black, such as in blindness, that in no way should change the continued existence of this external reality. So a tree is still there, the moon still shines, whether or not you're looking at them. And they may have an independent existence. True, a dog may see autumn maple in shades of gray, can't see color, or an eagle may be able to perceive greater detail, but most creatures, according to this way of thinking, basically apprehend the same object, the same reality, which persists even if no eyes are observing. But this issue of is it really out there predates biocentrism. Again, once you fully understand that there's no independent external universe out there outside of biological existence, the rest more or less falls into place. So where exactly is your refrigerator? Where in the universe is it located? So start with everything that's currently being perceived. This room, for example. We all think it lies in the external world, but we've all already seen that nothing can be perceived that isn't already interacting with our consciousness. So since the images aren't imaginary, it must physically be happening somewhere. So the human physiology textbooks are very clear about this. They say, that the eye responds to particles that deliver little bits of energy that are, hit the retina or photoreceptors, and then they're channeled back through these heavy-duty cables to the back of the brain, where the perception of the images actually occurs physically. So this process is augmented, of course, by other nearby parts of the brain that are as vast as the hallways of the Milky Way. Thus, according to human physiology textbooks, that is where actual colors, shapes, and movement happen. And that's where we perceive and cognize things. But can you actually access this visual part of your brain? It's easy. You're already doing it effortlessly right now with every glance. Custom says that what we see out there that's outside us. But such a viewpoint is necessary in terms of language and utility, such as please pass the butter that's over there. But make no mistake about it, the butter itself only exists in your mind. It's the only place where visual images are perceived and hence located. So explained in the language of biology, the brain turns impulses from our senses into an order and into a sequence. As the light bounces off the butter, various combinations of different wavelengths enter into our eye and then deliver the force to trillions of cells. And then in the brain, this information, which of course has no color in and of itself, appears as a yellow block of butter. Even the smell and texture of the butter is experienced in the mind alone. So bottom line is the butter isn't really out there, except by conventional language. The same is true for all perceived objects. Even the brain itself, the cells, electromagnetic events that we detect with our instruments, all of these are already been given a spatial temporal structure that the mind imposes. So we may imagine that there's two worlds out there, one out there and one inside our skull. But this two-world view is a myth. As we've seen, there's only one visual reality that exists, and that's the one that requires consciousness in order to manifest. Nobel physicist John Wheeler once said, "No phenomena is a real phenomenon until it's an observed phenomenon." The major handicap in adopting this new viewpoint is that language is created exclusively through symbolism to divide nature into parts and into actions. And even if you're well acquainted with the limitations of language, we always have to be on guard to dismissing things such as biocentrism too quickly because it doesn't at first glance seem to be compatible with the ordinary, customary construction of language. So the challenge, alas, is to peer beyond our habitual ways of thinking and to go beyond the tools of thinking, the thinking process itself. We need to grasp the universe in a way that is at the same time simpler and more demanding than we're accustomed to. So quantum mechanics describes the tiny world of the atom and its constituents with stunning accuracy. But in many ways, it threatens the absolute notions of space and time. When studying subatomic particles, the observer appears to alter and determine what is perceived. The presence of the experimenter is hopelessly entangled with the attempt to what you're observing and the result that the scientist gets. In 1964, John Bell proposed an experiment that could determine if separate particles can influence each other instantaneously over great distances. First, it was necessary to create these bits of matter that shared the common wave function, using a special kind of crystal. And these particle pairs are called entangled particles. And we know that everything in nature has both a particle nature and a wave nature, and that the particle's behavior exists only as probabilities. Objects assume particular places or particular motion when its wave function collapses. So what accomplishes this collapse? Messing with it in any way. So hitting it with light, taking its picture, would instantly do the job. But it increasingly became clear that any way the experimenter could possibly take a look at what was going on collapsed the particle, or the wave function, into a particle. So as more sophisticated experiments were devised, it became obvious that just mere knowledge in the experimenter's mind is sufficient to cause the wave function to collapse. That was freaky, but it got worse. If the wave function of an entangled particle collapses, so will its partner. So when they're separated, say, by the width of a universe, this means that if one particle has an upspin, when you look at it, its other particle instantly go spin down. And it doesn't matter where it is. So this has been done over and over using fiber optics, and it turns out that the act of observation does indeed instantaneously cause the particle to collapse and to take on the opposite spin. And they act as if there's no space or time between them. In experiments from 1997 to 2007 have shown that this is indeed the case, as if they're endowed with a kind of ESP. And they prove that Einstein's insistence that nothing can influence anything faster than the speed of light is wrong. Rather, the entities are floating in a field of mind, as biocentrism would maintain, that's not limited by this external space-time that Einstein theorized a century ago. But no one should imagine that there's only one aspect of quantum theory that supports biocentrism. We can go through other ones, but again, Bell's theorem has been shown experimentally to be true over and over. And before Bell, it was thought to be increasingly possible, though iffy, that local realism, that is an objective, independent universe, could be the truth. And before Bell, the people also clung to the old assumption that physical states exist before they're measured. And before Bell, it was widely believed that particles had definite properties, independent of the act of measuring. But all of this is finished for keeps. And quantum theory also casts doubt on the existence of time itself, which is very important to any fundamental look into the nature of the cosmos. And it turns out time is a biocentric fabrication. When people speak of time, they're usually referring to change. But change isn't the same thing as time. When you measure anything's position exactly at any given instant, what you're really doing is locking in one static frame of say, for instance, of a movie, as in a film. And conversely, as soon as you observe momentum or movement, you can't isolate those individual frames because momentum is the summation of many frames. So sharpness in one parameter is blurriness in the other, Heisenberg's uncertainty principle. So to understand this, consider the movement, consider you're watching a film of an archery tournament. The archer shoots the arrow and the arrow flies. The camera follows the arrow's trajectory and the archer's bow goes towards its target. Suddenly the projector stops and it locks onto a single frame of a still arrow. And you stare at the image in the middle of mid-flight, and you know it's positioned with great accuracy. It's just beyond the grandstand, 20 feet above the ground. But you have lost all information about its momentum or where it's going. Its velocity is zero. So its path, its trajectory is no longer known. It's uncertain. And so time is simply the animal sense that animates the still frame, so to speak, of the spatial world. It's our tool of perception. So at each moment we're on the edge of a paradox that was described by the Greek philosopher Zeno a very long time ago. Since an object can't occupy two places simultaneously, he contended, an arrow could only be at one place at any given instant in its flight. So to be in one place, however, is to be at rest. So an arrow must therefore be at rest at every instant of its flight, and therefore motion is impossible. But is this really a paradox? Or rather, is it proof that time, which involves motion, isn't a feature of the external spatial world? Rather, it's a conception of thought. So it's not really a paradox. So in addition to the uncertainty principle, there were other experiments that confirmed Zeno was right. Scientists have proved in the quantum equivalent of demonstrating that a watch pot doesn't boil. This behavior is known as the quantum Zeno effect. And it turns out to be a function of observation, and it turns out that the act of actually looking at an atom prevents it from changing. So theoretically, by the tenets of the quantum Zeno effect, if a nuclear bomb were watched intently enough, it wouldn't explode. Not that I'd recommend you trying it. You'd actually have to watch it, keep checking its atom every million trillionth of a second, which would be pretty tough to do. But they've actually done in real experiments where they use beryllium ions at the National Institutes of Standards and Technology, where they've actually shown this to be true. There were new versions that were just published actually a few months ago. So it's hard to believe that this could be real. I mean, this sort of a bizarre effect. The problem lies not with the experiments, but with our way of thinking, with our failure to accept the evidence. So while Zeno's paradox can be explained through these sophisticated mathematical concepts, mathematics is just a way to quantify phenomena, and it shouldn't be considered a replacement for it. The whole idea of science is to understand what's going on in the world in ways that we humans can understand. So the uncertainty principle is a fact, quantum Zeno effect is a fact, and biocentrism is the only humanly comprehensible way to explain them. And quantum phenomena are only weird in the context of the existing scientific paradigm. And this isn't just idle philosophy. This concept has been supported by a series of recent experiments. In 2002, scientists actually showed that particles of light, photons, knew in advance what their distant twin would do in the future. So they tested the communication between these pairs of photons. They let one photon finish its journey, and it had to decide whether it would be a wave or a particle. And then the research actually stretched the path of the other particle, so it took a little longer to reach its detector. However, you could add, the experiment could add a scrambler to mess up the photon into that second path. And it turned out that that first particle knew before you actually added that scramble whether you would or you wouldn't. So that was weird. So you say, okay, that's crazy. And they've done more experiments. So, okay, consider another experiment that was just published a couple years ago in the prestigious scientific journal Science. Scientists in France shot photons into an apparatus, and they showed that what they did could retroactively actually change something that had already happened in the past. So what happened is they put these photons into the apparatus, and it had to go through a fork. And as it went through the fork, it had to decide whether it was going to be a wave or a particle. And then it went on its way, and later on there was another fork. And the experimenter had the ability to click on a switch, an electronic switch, to decide what to do. And what that experimenter did then, right now in the present, actually changed what that particle did at that fork. That's real. We live in that same world. Now, physicists and scientists like to get out of this by simply saying there's two worlds. There's this small world, that applies to quantum phenomena, and then there's this macro world where everything's different. So the laws of the universe are different for you and I, and somewhere, I don't know whether it's here or there, the laws of physics change. And it turns out that that has been shown, not only does it not make sense, but it's been shown experimentally to not be correct. There was a paper actually in Nature last year that actually showed that entangled particles, when they were separated, actually were able to act indeed as if there was no space or time between them. There was an experiment that was done with these molecules called buckyballs, these huge carbon-60 molecules, and they actually in the macro world, and they actually turned out to exhibit the same quantum properties. And then there was an experiment done in 2002 with crystals, and they actually showed quantum ridges that were half an inch high. So again, okay, so those laws apply there, but where do they stop? Somewhere the laws change. It's just crazy, and there's no basis and reason. And more importantly, more and more experiments, quantum superposition, are showing that those characteristics that we are observing in the micro world happen in the world of you and I here in the real world. And that's where you start running into problems. This is where biocentrism tries to put it together to make sense. So in conclusion, and I just got my 2-minute thing here, we think that there's an enclosing wall, a circumference to us. But Bell's experiment implies that there are cause-effect linkages that transcend our ordinary classical way of thinking. The walls of space and time are illusions. Science is just beginning to grasp the nonlinear nature of reality. Heisenberg, whose famous uncertainty principle transformed our understanding of the world, once commented, "Contemporary science, more than at any previous time, has been forced by nature herself to pose again the question of the possibility of comprehending reality by mental processes. Alas, the evidence, the weight has the weight of a boulder, and shall our vision continue to flow over it? We're not just a collection of cells and molecules that classical science describes. Hans Pagel, the esteemed theoretical physicist, once stated, "If you deny the objectivity of the world unless you observe it and are conscious of it, as many prominent physicists have, then you end up with solipsism, the belief that your consciousness is the only one." And that reminds me of, the first thing is I should say is that I think Pagels is right. The only thing here is it is not just your consciousness that's the only one, it's our consciousness that's the only one. So the old Hindu poem says, know in thyself, in all one same self so, banished dream that sunders part from whole. The mind transcends space and time in that they're its tools, not the other way around. This concept of reality dissolves away human individuality. Sometimes, said Thoreau, as I drift idly on Walden Pond, I cease to live and begin to be. The walls of space and time are illusory. This is the prelude to immortality. We're forced to recall the words of the English poet John Doe. Never send to know for whom the bell tolls, it tolls for thee, and to understand them in a more scientific way. The great naturalist Lauren Isley once said, there are very few youths today who will pause, coming from the biology class, to finger a yellow flower or poke in friendly fashion at a sunning turtle on the edge of the campus pond, and who are capable of saying to themselves, we are all one, all melted together. That's it.